Okay, students. So in the previous videos, we have learned about sodium chloride. So sodium chloride is the first substance we have learned in the whole chapter. We know sodium chloride is an ionic compound and it has high melting point and boiling point, right? Let's have a look about the video. How do we melt sodium chloride in the laboratory?
Nice.
I like that tight blue tone.
Yep.
It's nice and hot. You see that orange color?
Yeah.
That's characteristic of sodium being ionized.
Okay. Huh.
If you come and you look real close, you can see the droplets forming.
Oh, you can, yeah. Oh, yeah, that's so cool.
Okay.
That is awesome.
Wow.
So you can see it starts to melt under high temperature with your Bunsen burner. And when we have looked about the picture on in the middle, so you can see the picture of dry ice. So dry ice, which is the solid form of carbon dioxide, its appearance looks similar to sodium chloride. However, if we put dry ice in the room temperature, so let's have a look about what will happen.
Carbon dioxide. Carbon dioxide does not have a liquid state under normal atmospheric conditions, so it turns directly from a solid into a gas as it is warmed. As it turns into a gas, it creates a little layer of gas underneath the dry ice, and so the dry.
So as you can see, okay, dry ice, okay, can change into the gaseous form quite easily in the room temperature. So that's why we can say carbon dioxide has a low melting point and boiling point. As you can see the heading of this video, which is called sublimation. Sublimation means a substance change from a solid to gas immediately without the formation of liquids. And on the right, you can see ice, which is the solid form of water. So from our daily experience, we know that ice does not require strong heating to melt it. You just put it in the air and it itself will melt spontaneously. So that's why we can say dry ice and water, that means carbon dioxide and H2O, they have low melting point and boiling point. And now we have to ask ourselves, if sodium chloride has a high melting point and boiling point, but for dry ice and water, they have low melting point and boiling point. So how come there are different results, even they have similar appearance? We can explain based on the structure and bonding, right? So that's the idea of the whole unit. Structure and bonding of a substance can explain the physical properties of a substance. So for sodium chloride, okay, we know there is a strong ionic bond between the cations and anions. And that is a joint structure because the cation and anion, they just join to each other repeatedly, okay, to form a huge structure. So that huge structure contains a lot of strong ionic bonds. And so that's why we say we need to break this strong bond in order to melt sodium chloride and results in high melting point and boiling point. So similarly, okay, if the dry ice and then the water can easily change their physical state. So now we have to ask ourselves, how should the crystals look like? Think about the first question. Should the bonds involved in melting and boiling be weak? Do you think the bonds are weak in both carbon dioxide and the water? I mean the ice. Yes, right? Because the weak bond, okay, just little amount of energy will be required. And then you can break it down easily. So it has a low melting point and boiling point. Second question, should they have joint structures? That means the particles, in this case, it will be the atoms just linked to each other, okay, repeatedly to form a joint structure. It should be no, right? because we know based on its low melting point, boiling point, the structure shouldn't be giant. Otherwise, it will require to break a lot of bonds. Instead of giant structure, carbon dioxide and also the ice, I mean the water, they have simple structures. So what is simple structure? So now take out your notes. And now turn to page 8. Simple molecular structure. In grade 9, we learn about ionic bond and covalent bond. So ionic bond is formed between a metal and a non-metal, right? But for covalent bond, it will form between two non-metal atoms. So the examples involved. For example, when there are two hydrogen atoms, they bonded to each other with covalent bond. So I hope you still remember the structural formula. It will be HH, right? So that is the single bond between hydrogen atoms. And then for oxygen, there will be OO. So O2, also the atoms bonded with strong covalent bond. And some of the other compounds, just like carbon dioxide and water, still remember its structural formula. So carbon dioxide will be C double bond O, and H2O will be single bond H. So these are the covalent substances forming by non-metal elements. So for strong covalent bonds, okay, please take out your highlight pen. We know the atoms are bonded by strong covalent bonds. But as we have understand, there should be weak bonds also involved. Otherwise, we can't explain the low melting point and boiling point. Covalent bond in the molecular level is considered as strong, just like ionic bond. So besides the strong covalent bond, okay, between the atoms, there will be a weak force, which is called weak van der Waals force. Students, take out your pen. Sorry, there's a missing important word. It's called weak van der Waals force. So van der Waals force is a kind of weak force. Be very careful about the spelling. So it should be small letter V, small letter D, W. So W is a capital letter, and the apostrophe, okay, is behind the S. So be very careful about the correct spelling of the weak van der Waals force. Weak van der Waals force, it exists between the molecules. So what does it mean? When we have to talk about the dry ice picture again, write down, this is the carbon dioxide solid. I use the symbol S to represent solid. And can you see there are some gases coming out? So this is carbon dioxide gas. No matter it's the solid form or the gaseous form, okay, so the molecule itself doesn't change. It still keeps as CO2. So the molecule doesn't change. We can say this is the carbon dioxide solid. This is the carbon dioxide gas. In other words, when we try to heat up the dry ice, it changes to the gas. It means the whole CO2 doesn't break down. It still keeps as a chemical formula, CO2. We found that, okay, between the atoms, okay, can you write it down? So these are the atoms. So between the atoms, there will be strong covalent bond. In my picture, where is the strong covalent bond? Let's see. Take out your highlight pen. Strong covalent bond between the atoms. And this is a molecule. So between the molecules, there will be weak van der Waals force between the molecules. So between the molecules. Weak van der Waals force, okay, is created due to the electrons, okay, in the molecule. For more detailed explanation, it will be introduced at the end of this school year. So at that moment, you just need to know that weak van der Waals force exists between all kinds of molecules, any kinds of molecules. So we can just make down the conclusion here. So mark it down. Carbon and oxygen atoms are held together by strong, okay, covalent bond. okay? But for molecules, they are held together by weak, okay, van der Waals force. So weak van der Waals force in my 3D diagram, where is it? It will be existing between the two molecules. So this will be weak van der Waals force, understand? Okay, so, and then the others, okay? So between two molecules, if they are close enough, then it will create weak van der Waals force due to the electrons in the molecule. And this force in the molecular level, so is considered as a weak force, which means it just requires small amount of energy to break it down. That's why we can explain the question. Under room temperature, dry ice become gas. Do you think the covalent bond in dry ice are broken? Answer should be no, right? Because we know that under heating, in this case, we are talking about sublimation of dry ice. Okay, so sublimation, remember, is the change of solid to gas without the formation of liquid. So there's no liquid in between. So during the sublimation of dry ice, the weak van der Waals force are broken. So probably I write more. We say the weak van der Waals force between molecules are broken. Between molecules are broken. Okay, while, I mean without, sorry, I should say without, okay, breaking the strong covalent bond, okay, between the atoms. So remember, for molecules, okay, when we try to heat up, you will break the weak force only. So once the molecules separate, then they will be changed from solid to liquid and then to gas. To better understand the whole idea, I'm going to use H2O as an example. So you better turn to page 9 of your notes. What we have thought about these pictures actually is not very clear enough. Okay, I hope you can understand. Actually, for each of the blue ball here, they are representing a oxygen atom, and actually for each blue ball, there will be two white ball. Actually, they are representing the hydrogens. So each of the H2O molecules, okay, there will be 3 atoms. Okay, so between the atoms, there will be strong covalent bond. Let me draw another molecule. So this is H2O molecule. So I just draw here. So it will be H2O. Okay, another molecule. Okay, I can draw it very nicely. I hope you understand. There will be electron pair being shared. Okay, so again, in H2O molecules, the atoms are bonded by strong covalent bond, but actually between the molecules, so between the molecules here, there will be weak van der Waals force. So this is weak, okay, van der Waals force. So van der Waals force exists between all kinds of molecules. Keep it in mind. You can see between van der Waals force. Let's say parts of the van der Waals force are broken. So the movement of the molecules will increase. So it will change from solid to liquid. So we can say partial van der Waals force has been broken. But if almost all the van der Waals force have been broken, that means molecules can further separate away. Then it will change to gas. That's why we say when ice change into water, so it involves breaking part of the van der Waals force. And This is what we call as melting. If more van der Waals force are broken, so it will involve boiling to change the liquid water into the gaseous form of water. In this process, no matter is H2O ice, solid, the H2O liquid, or the steam. So the chemical formula just keep unchanged. The molecules still keep as H2O. Okay, their difference is due to the amount of van der Waals force that can hold the molecules together. This process does not involve, so no new substance form, no new substance forms in the whole process. In other words, we say this is a physical process. But let's have a look about another flow chart. If water, the covalent bond between the atoms are broken, so it will be H2O, water, it will become hydrogen. When we talk about a substance, in a reaction, we are talking about the molecules that can exist in nature. So hydrogen will be represented by H2 and oxygen will be O2. During this process, new substance form. So that's why we call it a chemical process. Always remember, during heating, it only involves breaking the van der Waals force, but do not involve breaking the strong covalent bond. Have a look about the checkpoints. Question 1. Which of the following statements concerning the structure of solid, that means the dry ice, is correct? First one, it has simple molecular structure. That's correct, because it's a molecule, so it has simple molecular structure. Statement 2, carbon and oxygen atoms within the molecules are held together by strong ionic bond. So that will be wrong, right? So what's the bond? Yeah, it should be covalent. Statement 3, carbon dioxide molecules are held together by weak van der Waals force. So that's correct. So answer will be C. Have a look about question 3. During heating, ice melts. So which of the following statement is correct? Well, we melt the ice. So you remember, melting and boiling only involve van der Waals force. So only these two can be the possible answer. And van der Waals force exists between the molecules. So that's why only A will be correct. So I would like you to write down something, in this space. Except carbon dioxide and H2O, any other examples of substance with simple molecular structure? Of course, it would be yes. As I've mentioned, van der Waals force can exist between any kind of molecule. And once there's weak van der Waals force between the molecules, and then we can say the structure is called simple molecular structure. So let me give you more examples. For example, this is called molecule 1. Let's say I have molecule 1, which is N, nitrogen gas. So this is molecule 1, and I have molecule 2. Let's use the symbol N to represent it. Between the nitrogen molecules, there will be a weak force joining together. So this is weak, van der Waals force. So the weak van der Waals force holding the two molecules together, and that structure is called simple molecular structure. Let's use more examples, just like HCl. HCl molecule 1 and HCl molecule 2. So between the molecules, again, there will be weak van der Waals force. More, NH3. This is what we call as ammonia. So all the atoms, you can see they are non-metals in all the examples I've mentioned here. So I have the molecule 1, ammonia molecule, and molecule 2, holding by weak van der Waals force. So the last two examples will be quite strange to you, which is about the noble gas, argon. Argon itself doesn't carry any covalent bond, within the molecule. But argon, because it's a non-metal, and between argon atoms, or you can call it molecule, there will be weak van der Waals force. Because I've mentioned weak van der Waals force is caused by those electrons. And it happens on the non-metal atoms. So argon, they are called atoms. At the same time, argon is also called itself, is called a molecule or called an atom. Both will be correct. So similar idea can be applied to helium. Okay, so helium atom or helium molecule with a weak van der Waals force. So these are all the other examples of substance with simple molecular structure. And now question 2, chlorine has a simple molecular structure. What does it mean? It will be Cl. So chlorine molecules, again, held by weak van der Waals force. So you are asked about which of the statements is correct. First one, weak van der Waals force hold the 2 chlorine atoms to form a molecule. Do you agree? The force holding the 2 atoms together is called strong covalent bond instead of weak van der Waals force. So that's wrong, right? So, and then for option B, each chlorine molecule contains 2 chloride ions. Do you think these are called ions? No, right? Ion only happens in an ionic compound. So that will be between chloride, actually it should be called chlorine atom. And then the symbol will be Cl. So this is also wrong. C, chlorine molecules are held together by covalent bond. So it will be wrong. The chlorine molecules should be held together by van der Waals force. So answer will be D. Understand? Chlorine is a halogen. So halogen are the elements with non-metal atoms only. So that's why if we turn back to page 8, iodine has the appearance look like this. So this is iodine solid. And iodine molecule is look like this. So it will be, if I draw the electron diagram, then it will be like this. Okay, sorry, that's wrong. I'm afraid I won't have enough space, so I draw it here. So this is iodine. So they share electrons and form a single bond in between. So between the atoms, this will be the strong covalent bond. As you can see, the shared electron in my electron diagram. So strong covalent bond between, okay, atoms, right? Okay, so I just skip it, okay. And then there will be weak van der Waals force, okay, between the molecules. So that will be weak, okay, van der Waals force. So we can mark it down. The iodine atoms are held together by strong covalent bond. But the iodine molecules are held together by weak, okay, van der Waals force. Understand? Okay. If we understand the simple molecular structure with the molecules forming by non-metal atoms, then we can do the checkpoints. So can you turn to page 10? Based on the structure and also the wave force we have learned, then we are able to explain the difference of chemical of physical properties of simple molecular substance compared to giant ionic substance. Firstly, simple molecular substance can be solid, liquid, or gas at room temperature. It is quite easy to be understand, okay? Because, okay, for example, dry ice, it is solid, but it is not in room temperature. For example, iodine, iodine is a solid in room temperature. Liquid, for example, water, okay, and gas, for example, carbon dioxide. So they can exist in different physical states. However, no matter a solid, liquid, the melting point and boiling point involved should be relatively low compared to ionic compounds. So secondly, simple molecular solids just like iodine, just like dry ice and ice, okay, they are brittle. Brittle, that means quite easily broken, and they are soft, which means we can change their shape, okay, without not much difficulties. So they are brittle and soft because the bonding in between the molecules is weak van der Waals force. So because they are weak van der Waals force between molecules. So that's why it just requires small amount of energy to break down the molecules, and it will be brittle and soft. And then the melting point and boiling point will be low, right? So the explanation is quite simple. It's again due to the weak van der Waals force between the molecules. And I would like you to highlight one more point, which is about the energy. When we talk about melting point and boiling point, actually you are talking about the energy involved to break the bonds. So you have to refer to your answers, okay? You have to relate your answers to the amount of energy required. Point 4, okay, it's about electrical conductivity. So in the previous part, okay, for ionic compounds, we know that when ionic compounds become molten or in the aqueous solution, so it will become, the ions will become mobile. So once you have the charged particles, that is an important word. Once you have charged the particles, so just like ions and electrons, then the substance can conduct electricity. But for molecules, I use H2O as an example. Okay, so after heating, after decomposition, we know that it may become hydrogen gas and oxygen gas. Okay, so of course we need double amount of H2O to become there will be 2 H2 and then 1 O2. So once you decompose H2O and form 2 hydrogen gas and 1 oxygen gas, you can see these are still the atoms, okay, joining each other with covalent bonds. So they are electrically neutral. So this is neutral. This as a whole is a neutral. As a whole is a neutral. Even I further separate into the corresponding atoms. So the atoms are still be neutral, because in this case, I know that the atoms, okay, with a number of proton, it will be equals to number of electron. So they are all neutral. That's why simple molecular substance, they will become insulator, or you can say poor conductor of electricity. Okay, because there's no, okay, so in our answers, you better say because there's no mobile ions, okay, or electrons to conduct the electricity. So don't simply say there's no charged particles. Okay, you have to specify what's the charged particles that are absent, okay, in your structure. So no mobile ions, no electrons. For the solubility, okay, you don't need to know much. You just need to know the ideas. Simple molecular substance, they are, okay, for example, iodine. Iodine is relatively insoluble, okay, in water, but it's quite soluble in the organic solvent, just like cyclohexane and acetone. So detailed explanation will be explained in Unit 24. And here is the checkpoints. Which of the following statements about simple molecular substance are correct? 1, they have low melting point and boiling point. That's correct, right? They are poor conductor of electricity. Correct. They must be gas. This is wrong. It can be liquid, it can be solid, but the melting point and boiling point involved will be relatively low. So that's why only 1 and 2 are correct. Last question. Hydrogen chloride has a low boiling point. So remember, when we talk about boiling, melting, so we are talking about the low boiling and low melting point, which is related to the weak force. And this weak force exists between the molecules. So answer will be C. So when you are doing your fundamental questions in the exercise and you have any questions, you are feel free, okay, to ask your grade 9 chemistry teacher. Okay, so see you on the tutorial date.